Hi, everybody. Good morning. It's 23rd of February, and this is the Census R4 webinar. I'm pleased you can all make it. It's going to be presented by myself, Jonathan Brindley, Census Solutions Manager at JBUAS, and also I've got joined with me Marcus Shakora from Census, who is a applications engineer.
Morning.
So let's get started. So just a quick look at the agenda. A little bit about JBUAS. We're then going to look at the solution components, look at SkyHub 3 and True Train following and how that is integrated. I'm then going to cover Census, the Census R4 magnetometer in a little bit more detail and look at actually how it is put together and its connections. Look at some of the applications, some of which we've done, some of which we're aware can be useful. And then I'm going to review the some data and just make some statements on that from some observations, let's say. I will then hand over to Marcus, who will then be talking about the data tool, the Census Data Tool, and the Census Magneto. And then at the end, we're going to have a Q&A, and I'm sure there's going to be a lot of questions in the Q&A. As I have got Marcus with me, I'm sure they can be quite detailed, so don't hold back. So a little bit about JBUAS. So yeah, we're a reseller integrator for Census, and essentially working quite closely. And as you can see, just below that JBUS logo, we are also talking about a new sort of service that we can provide customers in the UK. It's something that we've been talking to Census about for a while, and it's also something that our customers are talking to us about, and anything to help the customer service move along is always a good thing. So yeah, yeah, if you've got any questions on that, then yeah, please get in touch. As well as Census, as you all be aware, there's we also deal with a lot of other sensor manufacturers as well, and these are covering the kind of integrated systems you can see. So we're covering methane, metal detection, ground penetrating radar, sonar, echo sounder systems, thermal, and of course the Census magnetometer systems as well. So yeah, if any of these things are of interest to you, then please get in touch. If you haven't seen the LinkedIn post or the LinkedIn page, please go and have a look. There's lots of different applications on there where these kind of technology has been used, especially the magnetometer system from Census. So let's have a quick look at the solution components. So the solution looks like this. We have, when I'm talking about a DJI M300 RTK as the drone of choice here. So we have the M300. We then have one, which is the Census R4 magnetometer, and you can see that long pole there. We then have the Census R4 data recorder, and the R4 has its own data recorder. So you can see that there identified as 4. We then have the UGCS SkyHub, which is on the side of the leg there. You can see it, a little box called the onboard computer. And we also have the UGCS True Train following feature, which is part of that feature is the radar itself. And you can see that position number 4. In this case, we positioned it directly below the recorder. It's an ideal place for it. And yeah, it provides stable flight. Also included in this sort of setup, we also have the fastening cradle, which allows the recorder to be connected. And I'll go into that a little bit later. And there are also 2 cables required for the R4. One is for power, identified there, and also one for the GPS data. So what we do is we feed the GPS data from the SkyHub into the R4. It doesn't have its own GPS, and therefore we send that in. Also on there, you can see the 5 sensors, which we'll go into a little bit later on as well. The sensors here, F1, F2, F3, F4, and F5. So let's look at the SkyHub and TTF integration. So what's SkyHub's role? Well, SkyHub is syncing with the M300. It's allowing the UGCS Pro mission control software to talk and through trade following to talk to one another via the what's called custom payload monitor. And custom payload monitor is something we'll go into in on the next slide. It's also got a job of managing an obstacle detection radar if it's fitted. So what we can do is if you're flying quite low to the ground, it's not uncommon for people to miss branches from trees, and if you're not careful, you can simply fly it into one of these, and your drone is lost. So the ODR can be set up to stop that happening, yeah, it's proving quite useful. And then the last two on here we can also see is the role of the SkyHub is, and I mentioned this on the last slide, is to provide power for the R4. So we're pushing the 18 volts into the R4, which is the required voltage that the R4 requires, and that is adjustable. You'll have to excuse this picture here because it's actually an older SkyHub. This was before it had its makeover. It looks a lot better than that now, which some of you who've got the new SkyHub will know. Its other role is to send that GPS feed into the R4 recorder as well. And again, another shot here, you can see here the TTF radar underneath the recorder. So you can see that set up there, your pole, SkyHub, recorder, and you can just see the bracket as well that we talked about in the last slide. So hopefully that's clear. So we talked about the custom payload monitor, and so the CPM, what we call custom payload monitor, CPM and UGCS, they integrate within the system, and that's how we fly the R4. And essentially, the UGCS Pro will be used for planning the flight, so exactly where we want to take the drone, with the swath, and also we look at doing speed within the UGCS Pro. But in the CPM, which is a secondary piece of software which is uploaded when you buy SkyHub, it will allow you to make the settings for your target altitude and your safe altitude. So there are some settings that you would do in CPM, and there are some settings that you're doing UGCS Pro. But as what is different to CPM when you're flying an R4 is that we're not actually fusing any data within SkyHub. Those that are aware of other sensors like methane or ground penetrating radar, we do take the data in, we fuse it with the telemetry, and then we will allow you then, or the customer, to download it in a format that works for them. With the R4, it has its own data recorder. Therefore, as I mentioned before, we are simply sending the data in. So as you will see here on this picture, we are seeing data for gas detection, and actually we're also looking at wind speed as well. This is actually for a methane sensor. We wouldn't need to be looking at any other sensors other than true train following. So the altimeter and the true train following feature. They're the only two pieces of information you need to be bothered about once we're using CPM. So that's the main difference than another sensor. So let's have a look at the Census R4 airborne magnetometer. So it uses 5 times FGM3D sum5 fluxgate sensors. And now, why are these being used? Why were these chosen by Census? Well, they have a high sampling rate of 200 hertz. Now, that's a standard. Out of the box, it's 200 hertz. I mean, and as it's 200 hertz, it means that you can suppress and filter out a lot of other sources. You can identify, for example, 50 to 60 hertz. If you're flying nearby transmission cables, you can clearly see that in the data, and you can take that out. So yeah, that sampling rate gives you a lot of flexibility in regards to filtering out unwanted noise. Also, the flux gates allow separate measures of the X, Y, and Z by the very nature of flux gate. So you can measure the X, Y, and Z of the Earth's magnetic field, and it just provides a much richer data and a better interpretation. So it gives you a little bit more than you would from other technology, let's say. The flux kits also have compactness. They're small, they're light, which means they are very easily fastened, connected up to UAV and other similar technologies, and also they're easy to transport around as well. So the R4 box and full equipment, it isn't very heavy, and you can easily move it around when you're in the field. So that is a real bonus as well. There are, with other technologies, you do have, for example, dead spots at certain parts of the world, around the equator, for instance. With flux gates, there are no dead zones. So you don't have that limitation. So that's another reason why. And probably the most important one that has been very apparent to myself as I've collected and analyzed data is just how easy and simple the interpretation of the data is using the SENSYS process flow. Compared to other sensors and descriptions that I've had with other people, it's far simpler and much quicker to get results to customer when you've been out in the field collecting the data. And obviously that really, really helps. Marcus is going to go through, as we said in the agenda, Marcus is going to go through the data tool, and he's also going to go through Magneto a bit later, so you can get a flavor of what that actually means and what that process flow looks like. But it's really, really simple. So next slide. So some key features of the R4. So I've mentioned that there's 5 sensors. Each of the 5 sensors is 50 centimeters spaced, so that gives you a swath of 2.5 meters. So if for larger areas, and I'm talking 100, 200 hectares, let's say, it makes a massive difference to not only the cost but time-wise as well, when you're up against it. So being in the field, you can do a lot. You can cover a lot of ground compared to maybe other systems. For example, the sister R3. Goes without saying that coverage depends on the size of the targets. If you can fly higher and faster, then that's better. But so larger targets, for example, in regards to UXO, I'm talking about it mostly, maybe some utility as well. When you're able to fly higher, then the risk is low, and you can obviously do a lot more time, a lot less time to do what you've got to do. The internal recorder, as standard, provides you with 120 hours or can record up to 120 hours of data. So you're not going to run out of data space anytime soon, even with the standard supply. And as we mentioned before, the data tool will allow you some ability to take out unwanted noise, and we can filter that down to 1 hertz. So that, again, and this is something that can be covered in more detail by Marcus in his slide pack. The technology has a resolution of 150 picotesla with range plus minus 75,000 and a Tesla standard measurement range. Again, it's more technical. This is something that you can prize out more information in the Q&A. So yeah, I haven't said this up now, but yeah, please feel free to start asking questions in the Q&A. Like I said, I've got Marcus on call, and we'll try and answer as many questions as we can. So just to reiterate, I've got this chart here. You'll all recognise that, those who fly the M300. So it's just it just really just underlines that, and also it corresponds with the experience that I've seen of getting in most conditions around about 25 minutes to 30 minutes of flight time with the R4. So you can do a lot of surveying in that time. So it's a very handy bit of kit. So simple assembly. I mean, yeah, it's really simple to put together. I mean, 10 minutes is pretty accurate, actually. But you can see in the top right hand corner, you can see that we have a pole, and you can see that also in the picture as well, the two parts of the pole will be split, and you literally just plug them in together and twist and screw them together. It's quite simple, seconds to do. And then we have the other main part of the assembly is just to put on the fastening cradle onto the front of the M300. To do that, you will take away the gimbal mount. So you unscrew the gimbal mount and replace that with the cradle. And it is really simple. It just slides straight on, and you can see from the picture, bottom right, it's got its own little rails there, and it just slides straight on. And you wait until you hear the click, and then you move it. You can tell that it's firm, and that's it. It's done. It's quite simple. So connecting the R4 on is a really simple job. In regards to UGCS, Skyhub, and True Terrain Following, again, it's not particularly simple. It's more in the setup, the configuration, than the actual setting it up. And I think that there's many of you out there who will probably use Skyhub already, and are quite familiar with that. Yeah, so that's sort of its setting up. So sort of connections. Oh, go back one. Sorry about that. So in terms of connections, there's only 3 real connections. There was the first one is the one that I'm going to talk about is the Wi-Fi connection, which is used for data download, and I'll cover that in the next slide. The second is the connection which we touched on earlier, which is for power, and the third one is for the GPS input. So there's only, again, it's quite simplistic in its design and quite simplistic to connect together. The only thing I didn't talk about there actually is the radar position, and you can see I've just put in another little picture from the last slide there, just so you can really see that the True Terrain Following radar that we use is Velcro. It literally Velcro to the bottom of this securely, yeah, it provides very stable flight for the R4, and that is our. And what we found is that's the ideal position for the radar. So looking at the operation of the system and the data download and how that works. So you've flown your mission. Sorry, before you're going to fly your mission, you simply walk up to the R4 with it powered on and it's configured, and you're simply pressing the red button. You can see there, they usually say don't press the red button, but in this case you do press the red button, and you know that then it's working because you can hear every second a beep, and so that beep is really useful in the field because it gives you that assurance that the R4 is working. And the experience has shown us that it's very reliable. I mean, we get to the point where we're literally just pressing that button and hearing it 2 or 3 times, and we know that the data is going to be there at the end of it, and sure enough, it always is. So very simple operation. Once this R4 is set up, it is as simple as pushing a button, which is great. And it means you're quick to get out and collect data. So you've flown your mission, you fly the drone back, you land it, you turn off, you press to turn off the recorder, and you'll hear that it's off because the beep per second will disappear, will be gone. That file is now saved in the recorder. And you then need to download the recorder. So the way that Census downloads or enables you to download that data is a simple Wi-Fi connection from your laptop. You can position your drone next to a laptop in the field, and you can log in to the portal, and you are then simply just maneuvering your way to the data tab, and you can see on the right hand side, you can see this data tab, and your files are going to be listed there in chronological order. So it's again very easy to see what if you've done 2 flights yesterday, you've done 2 flights today, it's in chronological order. You can see what flights you've got in there, and it's very simple to download. So it's it's a click to download the data and copy the data onto your laptop. Very easy. So the files that you're going to get out from there, and I'm sure Marcus will talk about that in his slide pack. The file format is raw file format is pmx.lf. It's your file format you'll see all the time when using the R4, and that is the files that are going to be taken into Census Data Tool. And like I said, Mark is going to talk about that a little bit more. So it's still his thunder on that one. So applications. So anyway, before we get on to applications, I thought I'd put this slide in. There will be some people on the call that aren't, they're not engineers and they're not that familiar with how magnetometers work. But basically speaking, the amount of what can be measured decreases rapidly, or what can be measured by the magnetometer decreases rapidly the further you're away from the target. So basically, if you're wanting to find smaller ferrous targets, you need to be as close to the surface as you possibly can. However, the caveat there is that you're flying closer to the ground, so you need to be a lot more careful. So fly as close to the ground as you possibly can within your abilities, and so that it's so that you're being safe and it's practical. So that's the caveat I would say there. But generally speaking, magnetometers, there is a rule of what you can be seen and with distance, and but basically speaking, for those that aren't technical, flying it as close to the target as you can, or as less as small AGL as you can, is always better. But obviously, the applications don't always allow that. Crop, for instance, if you're doing, I don't know, it could be an archaeological survey. If the crops are there, you can't fly it anywhere. But generally speaking, below you. So let's have a look at some applications. So some of these I've been involved in, and some of them I've not been involved in, but there are obviously aware of people around the world doing these kinds of things. But certainly scouting UXO, the system was designed for that application, so that I've been involved in a lot of trials and projects regarding UXO, and I'm going to touch on that a little bit more a bit later, because I know there's a lot of people on here that are specifically interested in that. Mining applications, I've just been involved in a application in Canada for that, and I've put you a little pretty picture down in the bottom right hand corner. It's able to show you. That's just to give you an indication that the R4 is it can be used in mining as well. Detected buried tanks, mapping ferrous utility pipes, mapping power cables. Top right hand corner there, you can see we did a little trial for mapping power cables, and it was actually over a swamp. Which is quite apt actually, because my comment at the bottom is water does not affect the magnetometer's range. So water, you can fly over water, given your the ability, the capabilities of the magnetometer, and also the size of the target, etc. But you can map these power lines quite accurately, and you can see what the routes, as if in this case, if they've got a lot of power going through them. But also mapping archaeology, you can see the middle picture there is an example of sort of buried features below the surface, sort of like an old town, if you like. So I'll touch on that a little bit more as well, and we can cover that a little bit more. And then of course, artifacts, sort of small items in the near surface. It's quite handy for, maybe, if it's just under the surface, you may be able to see something that's almost 200, 300 grams. So, quite a handy bit of kit for that. Just bear in mind that it's not a metal detector. It will only detect things that are ferrous or iron content. So there are things like gold, aluminium, and things like that. You're just not going to see. Yeah, and then also bores, pitches, ditches. I mean, it's probably kind of linked to archaeology. But yeah, you can see there's a number of applications there. They're not always the obvious applications, but they are certainly. Archaeology is I think the technology is there now to really help archaeologists. Yeah, and hopefully we might have some news in the next 6 months or so for those that are dealing in archaeology. So that'll be just watch this space on that one. So some observations from myself. What I found is from working on a number of archaeology projects, it appears we can fly the R4 even at 1.5 meters, at 1.5 meters a second, and still get good indications on buried features. But for the best results we've achieved have been 1 meter or less at 1.5 meters a second or less. So there are limitations, but you can still get indications at 1.5 meters at a faster than walking pace. Also recent work that I've done has shown that when the R4 is flown at a similar height to a walk survey, so that's round about 0.6, if you've got fairly flat land, it's the results are I mean, they are very comparable to handheld surveys. So I think it's definitely improvement over the R3 from the grad survey I did 2 years ago. I think it was it last year? So yeah, it's very handy to in terms of being comparable with handheld surveys. And then lastly, with the UXO work that I've done, I'm pretty confident the R4 can identify sort of 50 kilogram targets given 1 meter and up to 4 meters. And then R4, yeah, 1.5 kilogram, around 1.5 kilogram, 1 meter, around up to around 0.5 meters. So yeah, that's sort of observations that I can sort of share with you. So just some data, just a quick data review. This was a trial that was done using the Magneto, SENSYS Magneto MXV3. As you can see, it's a cart-based system, with sort of 16 flux gate gradiometer. It's a it's a professional system. Anyway, 56 targets identified, and of those 56, so let's go to what we can say. So looking at this data, I'm not expecting everybody to see this, but you can, there will be a recording of this, and I can provide the slide pack and so on. So you're not going to go without the data. But this was a survey, a trial survey done by Census on a number of munitions. And what I can say is, yeah, there are some spurious data there, and the length of the target orientation will have a bearing on the results. But if you look carefully, your eyes are good enough, you can see that of the 56 targets identified by the MX3, the R4 missed only 12 of them at 0.6 meters AGL, and the majority of those were below 2 kilograms at more than 0.3 meters of depth. So as I've already stated before, my experience suggests that the R4 is capable of picking out around about 500 grams to around about 30 centimeters. So that's what I'm confident with. I'm sure there'll be some trials in the future, or some other work that will show it may do better in certain circumstances. But as a general rule, that's what I'm kind of seeing. So hopefully that's give you sort of like a sort of like, I know it's a whirlwind tour, and you can't really do very much with 25-30 minutes, but if that's of interest to you, then please get in touch. What I would say is, we can provide you know, everything you can see on the screen, but the one thing that I really want to bring to people's attention is the trial days. So if that's if you want us to get involved in the trial day, then please get in touch, and yeah, we can try and sort something out with you. Anyway, thanks very much for listening. That's my section of the presentation, and I'm now going to hand you over to Marcus from SENSYS. So I'll stop sharing, and yeah, the floor is yours, Marcus.
Hi, and welcome again to all of you. I will directly hop into the MagDrone data tool, which comes with the system, so it's free of charge. I can also share a link afterwards to the persons who are interested in, and they can trial by their own. We will process one data set. So it's a data set Jonathan already showed to you. It's from our testing field. But first of all, the very first display of the tool is the import section, and you see there's a lot more than the PMXLF import. So we have also import formats for other systems. So the R3, which is nearly kind of the same of the system, just with 2 sensors. Some older systems, MagDrone 1 and so on. We can also include calibration data. Yeah, but today we want to talk just about the PMXLF format. So it's a binary saved file format from SENSYS. So you will need the MagDrone data tool to open it. But you can translate and export it in many different formats, and that's the export section at the bottom of the tool. So, and there you can see we have the UXO64 format. That's our Magneto import format. Magneto is our post-processing software. We will have a look into that as well today. But you can also export this in ASCII formats. So the second format is ASC for custom further processing. That will include the same information than the Magneto format. So we will have track detection, we will have filtering, we will have compensation, offsets, and so on. But you can also use just our track detection. Then you need to export it as raw tracks. Then you will have just a track, so the crop tracks at the end without any filtering and compensation. Or you can simply translate the binary saved raw data into a readable format. So the CSV data output will just translate the binary file into a CSV format. Yeah, let's start with our testing field. So we will import the data. It will read the data and will show you the GPS path. So it's no magnetic data here. It's really just the GPS location. And you see we are measuring, as Jonathan mentioned before, we will press the red button at the start of the survey, and we will press it again when we are back with the drone. That means we will measure everything and recording everything. So we will record the start and the landing procedure. We will record all the turns at the end of each track. And first of all, we want to get rid of this. And therefore we have our track detection. You have several settings you can do here. What I'm doing first is the minimum track length to set this. So I just want really the long tracks in the middle. That means, okay, they are at least 60, 70 meters long. So I will choose 60 meters in this case, and we'll press detect once. And I see, okay, to be honest, I'm pretty good with it, with the first trial here. So all red lines will be cropped, and everything which is blue will be used for data processing afterwards. So that's a pretty easy field. When we have more challenging fields, the tracks are also numbered, and you could also type in, I will delete, I don't know, 4 to 6. Press detect again, and you will get rid of these lines as well. But I want to process all 6 lines. And I will hop to the next tab. It's called filters. And there I have a bunch of different options for filtering. Our recommendation and our default values are just the low pass filter with the cutoff frequency and the compensation. So low pass filter means everything which is above the cutoff frequency will be deleted, because all our magnetic values we are looking for are very low frequent, and everything which is coming from the drone is very high frequent. And therefore, we can easily filter the drone noise out of the data. I would recommend always something between 2, 3, maybe 4 hertz. It's a little bit depending on your surveying speed and the items you're looking for. The smaller the items and the higher the speed, the higher should be the cutoff frequency. But with 5, you're always safe. But we can also lower that down to 3 or 2. Compensation is important because we have, as Jonathan mentioned, we have 3-axis flux gate sensors. We have no gradiometers. So what we will measure at the end is, or what we calculate at the end is the total field. But what we want to have at the end is the magnetic anomaly. And therefore, we need to compensate our data. So we have different options. When we're looking for compact objects like UXOs, then I would always recommend the moving median with the 50-meter window length. That means the algorithm will calculate a median every 15 meter and will subtract this from the overall value. See, we have also the constant median. Constant median means it will calculate the median of the whole track, and overall median means it will calculate the median of the whole survey. I will stay as is here. We have also overlapping filters. But nowadays, where the drones are very, very stable and very accurate in flight procedure and planning, it's not needed anymore, to be honest. So I will leave that blank. These buttons here for frequency analysis and noise analysis are more or less to have a look at your data in a more professional view, and to see what has maybe a bad influence on your data. Then we have the next tab, offsets. Here you can set different GPS offsets, time offsets, location offsets, whatever. We're figuring out that the SkyHub, together with the M300, has a little bit of a time delay. Therefore, we need to set a time offset of minus 250 milliseconds, and then the data will fit together. We think it has to do with the translation from M300 within the SkyHub. Next tab is the MagBase tab. We can also include base station data, so magnetic base station data. For UXO, it's not needed. For exploration flights, it can be useful. And the last tab is the GNSS import. With this setup here, when we're getting the GPS information from the M300 and SkyHub, it's mainly not needed because we are getting the same accurate GPS than the drone has. So invest RTK fix when we have a correction service. But in some cases, especially when we're using the R3 with an internal GPS, we have the internal GPS, which is not that accurate, and we have the drone GPS. And with this tab, you could merge that together in post-processing. but I said it's not needed for the R4 now. Yeah, that's it for the MagDrone Data Tool. And when you are happy with all your settings, you can just tap on Export, and that will process the data. So we will create now a UXO64 file, and we will get also a preview. That's a not interpolated preview. You see, it's quite fast. Are you able to see the preview as well? Yeah, okay. So that's a preview of our testing field here. And you can use this, but you can also go to the Magneto. And first of all, I want to show you the features and advantages of Magneto. Second. So I said, Magneto is our post-processing tool or software. Key features are we can display the color-coded maps itself. It's also useful for borehole data. That's a different kind of sensors and application from us. We can do object calculation of compact objects. We can integrate site plans, pictures, company logos, whatever. We can create object maps out of these calculated objects and object lists with GPS position and so on that can be exported to a GNSS system or whatever to pick up the objects afterwards. We can simulate magnetic objects and signatures, and we can import and export many different formats also for other softwares from our competitors like Balloon or Geosoft or whatever. Main advantage of Magneto is really the fast map creation. It's getting really, really fast. The many and export formats and our geo server, which is included in Magneto and is able to and export your map or your layers or whatever in any coordinate grid, and you can also import your own transformations in it. So therefore, I will now hop into Magneto. Here we go. So it's document based. So we have a blank piece of paper, and every layer will be import on this piece of paper. So we will import our UXO file we created in the MagDrone Data Tool before. Here we go. And here you see in the page manager, we have all the different layers. So we have the color-coded map itself. And on the other side, we have the property window. And in the property window, we can change the layer we choose in the page manager. So I choose the color-coded map. And first of all, I want to change the scale, maybe to 32. There it is, better visible. So that's our testing field here. We can now calculate objects or during an export, for example, as a geotiff. That's what I want to do first. So therefore, I will mark the color-coded map, say export, choose geotiff. You see here we have a lot of different export formats. Geotiff. We'll just name it. Save it. Then I will go to our geo server. I will choose the correct EPSG code. It's 25. That's the zone we are located here. Apply, okay. And it will process my geotiff. When I go now, I can show that, for example, in QGIS. Just QGIS. So use Google Satellite as ground layer and choose my geotiff. To the layer. And here we go. That's our company premises here near Berlin, Germany. So it's fitting perfectly on our testing field here. Now back to Magneto. Second. Come on. Here we go again. So last thing I want to show you is the object calculation in Magneto. Therefore, we need to mark the color-coded map again. We go to total field object calculation, and then we have the possibility to pick objects in the map. So it's not working for any object, but for most of them. So we need to make sure that we will cover the object. And we can press calculate, and it will calculate the estimated object properties. So we have an estimated depth of 1.5 meter. We have a magnetic moment of 3.26 ampere square meter. And it's asking us if we want to take it over into our list. We say yes. Then we can go into our list. It's here, where we see the local position, depth, diameter, volume, and many else that can be changed here. So we have also the possibility to show the let and long in WJS84. We can show you the quality of the magnetic moment, many different stuff. So, and this list can afterwards be exported into a normal text file, ASCII file, and can be printed. That's the main features of Magneto, more or less. So there are more options, but you can do all your results, your documentation in Magneto as well, and create PDFs afterwards and send it to your customers. Yeah, that's it, more or less from my side. Still on mute, Jonathan.
All right, not anymore.
Yeah.
Okay, yeah, thanks, Marcus. That's really good. So yeah, we've got 10 minutes. Got some questions that I want to get through. The first question is it possible, Marcus, to see the SENSYS the actual output from the Census Data Tool? Because within the data tool you showed the procedure, but we didn't see the actual output from the.
You mean the file itself?
Yeah, the actual picture of what they can see in the field.
You mean the preview?
Yeah, the preview.
It wasn't that visible in the no.
No.
Right. Sorry. Yeah, it's additional window. Maybe that's why it's not visible.
Yeah, no, that's visible now.
Yeah, so that's the preview which is coming out of the MagDrone data tool.
Yeah, okay. So this is, yeah, okay, so this is coming out of, this is the result of the filtering in through the data tool. Okay.
Exactly.
So that's, yeah, you can see the targets there, even from the data tool output, and you can see the number of sensors on each pass. Yeah. Yep. I can see that. Yeah.
Exactly.
Okay. Good stuff. Okay, and then other question here is, I think it's probably one for me actually. Fastest speed. What's the fastest speed you can fly the R4? Could you fly it at 5 meters a second? Well, I think I know. I mean, you can fly the R4 at 5 meters a second, but it's still down to safety. It does have a high sampling rate of 200, and Marcus, I think I'm right in saying it's actually, you can, as a special build, you can probably get more than that. You can
get more of that and even 5 meters per second, and even with 200 hertz, it's not a problem at all. I mean, it's a problem in terms of safety, what you said, but it's not the problem of data recording, as even at 5 meters per second, we have a data point every 2.5 centimeters, and that's more than enough. So I can show you an example of a survey done with 5 meters per second. Just open Magneto. So that's 120 hectare of survey done in 4 days for 30 hectare a day, and that was done with 5 meters per second and 1 meter above ground. So it was a crop field, totally flat, perfect conditions, and there you can go 5 meters per second. And as you see, it's no.
Yeah, you need to be very careful about upstanders.
No issues with any spatial, sure. But in terms of data, it's no problem at all.
Yeah, no, that's good. Yeah, so other question is, what other formats can be exported from data tool? So, for example, Oasis montage.
You can export as ASCII-based table, and that should be importable in Oasis montage. Or it is. I know that it is.
Yeah. I also know that it is as well.
So
no, that's good. Also, just one that's come in here. Yeah, I know the answer to this one, but I'll leave it to you to say the answer. Is Magneto software covered as standard?
No,
does it come as standard?
It's additional.
Yeah,
it's not included in the system. The MagDrone data tool is included. The Magneto is additional.
Okay. The one I wrote down here is, can the R4 be used over salt water?
Yes. Salt water has no influence at all.
And what? Yeah.
So it's not like a GPR.
No. no, it's not like a GPR. So it doesn't have any bearing at all. Salt water has no bearing on.
As long as it is not a magnetic layer, it has no influence.
Right. Okay, that's good. Yeah, and we've already said that we can have a higher hertz rate if required. So how do we set up the RTK feed in SkyHub? So you set up when you have your training on SkyHub, when we first configure SkyHub, what we do is we go into what's called the config file, or the configuration file, and what we'll do in there is we will be setting a number of parameters within a specific section of the configuration file that allows SkyHub to be able to provide the correct parameters through to the R4. So it's not a difficult process, but it just needs to be done the first time you configure the system. For example, if you had a Sky Hub let you just use for that purpose, that you said, well, that's what we're going to be using, then you would set it up once, and then that would be it, basically. Yeah, it's a very simple process. It's literally a 5-minute job. So that hopefully that answers that question. Oh, just one other thing to mention, and I did mention it also in the presentation. One of the improvements that was made by SPH in the UGCS Sky Hub 3/2 is that the voltage can be changed externally to the Sky Hub. So you can, if you remember the picture that I showed you, and you had a little box on the outside, that is now that's where you that's where you can change the voltage output to this particular sensor that you're dealing with. So as I mentioned, in the case of the R4, it requires an 18-volt output. So that can be done from the outside, and so yeah, just to add that it saves, and it also saves a lot of time. Okay, wind speed. In regards to wind speed, yeah, I think that this comes down to wind is going to affect the R4 just like it would any sensor. The R4, you would have mentioned, it's a 2-meter long pole underneath your drone. Hopefully you've set your weighting up on your M300 properly, and you've got it correct. But wind can have an effect. I think as an experienced pilot, you've got to be able to look at, the limitations of flying the sensor, and you have a feel for that. But that varies between pilots. But yeah, I think you just have to be cautious in but as soon as you start getting gusty winds, then you've got to start thinking about, am I able to fly at 1 meter? It's sort of common sense, but that's very much down to the pilot, I think, to an experience. I mean, Marcus, have you got any comments on that particular question?
Yeah, the more so we also have to differ about crosswind and wind direction and so on. That's important, and the simple answer is the more the R4 is moving, the worse the data is at the end.
Okay, so just okay, thanks for that. So just another question that's just come in. Can magnetometric surveying identify void spaces in rock below the surface? And if so, what accuracy resolution can be achieved?
At the end, it can't be identified the voids directly because they are non-magnetic. But when you speak to a geophysicist, he would say maybe, and it depending on the surrounding rock. If this is a magnetic layer or not, you could identify the voids, sure.
Yeah. I mean, I guess,
but it's really depending on the surrounding rocks. Yeah,
I mean, I don't know if this is a UK based potential, but as I was mentioning earlier, within the last 4 weeks, we've done a mining trial in Canada. So if there's something that can be a possible trial there to identify whether this is going to save time and provide you some value in your operation, then get in touch and let's see what we can do. That's what I would say there. That's it. We've answered all the questions. So I think we are bang on. 10:59. We just so look, I want to thank you, Marcus, for coming on the webinar. I think it's been I think hopefully it's been really useful to everybody. It goes without saying that if you have any questions, please come and get in touch, because I know what it's like. You come out of the webinar and then you remember you wanted to ask something, or you see something and then you think, oh, I should have asked this question. Just get in touch. It's not a problem, and we'll, like I said before, we'll support you as best we can. Working very closely with Census now in the UK, and hopefully we've got this new service health check coming on, which will support existing customers. So thank you to all. I hope you've got a lot from it, and yeah, please get in touch. Thanks everybody. Thank you.
Thank you.
Thanks,
Bye-bye.
bye.